Quantitative data analysis techniques. When organizing data, there are four methods in doing so, these being range, rank order distribution, simple frequency distribution, and group frequency distribution. With range, this is when you get the difference between the lowest number and highest number out of the data sample. When using range, it is good to use it for data when there isn't an anomaly number, as this can make the range a lot larger compared to what the range would be compared to most of the numbers, as one can just be a lot higher or lower than the others, making the range not representative. So when all the numbers have similar differences to each other, it is good to use range. Range is used to detect errors in the data, as you can tell if the answers are wrong from the unrealistic range. For example, if you have a range of 2 meters for standing vertical jump, you know that this is wrong, as no one is going to be able to jump that high. With the example we have on the screen here, I picked out the results we got from the standing vertical jump. From this, we need to pick out the lowest number and the highest number, with the lowest being 15 and the highest being 56. And once this is being completed, we need to find the difference between these numbers. An easy way to do this is to subtract the lowest number from the highest number. So with this example, it would be 56 minus 15, which equals 41. Once you've got this, you have got your final answer and the range of the data. Rank order distribution is when you get the results from the data that you have found and you order them from lowest to highest, and is used when the numbers are is most commonly used when the numbers are below around 20. In this example, we use the data that we got from the skin fold calibers on the triceps, as all the answers were below 20, and is it easy to rank from the lowest being 3 all the way to the highest being 13. Simple frequency distribution carries on from rank order distribution, as it ranks them, but only using each number once instead of showing 2 or more of the numbers depending on how many results the number had. To then show how many of each number there were, the next column is for tallies of how many people each number had, and then showing it in numbers in the next column, it shows the tally and frequency. Then to finish it off, you do the commutative frequency, where you add on each frequency until you get the final answer of how many results you had, so you can see if you have done it all correctly. The example we used was the skin fold calipers on the triceps again, where we can clearly see how many of each number results we got and if we did our findings correctly. Group frequency distribution is very similar to the sample frequency distribution, as it has the same format but is different in it has a group of numbers and is most likely used if there are lots of different numbers recorded from the results and not many people got the same results. This is why it is common for decimals, as it is unlikely for people to get the same decimal place results in testings. The example we used was the flying sprint start, as this was recorded in seconds with decimal places, so not many people got the exact same answer, but we're all very close and within less than a second difference from the quickest to the slowest. Part 2. When presenting data, there are 6 different ways to do so, and they're shown on the screen here, and with these they all require certain aspects to these charts and graphs. A scientific title, the axes labeled regular intervals, variables on correct axes, so they're independent on the x-axis and dependent on the y-axis, and then choosing the right type of graph for the data that they have. The first being a line graph. A line graph is best used to compare data. It is a graph that has each result put down as points, and then the points are connected by lines to show the change as time goes by. Large overlap can occur when comparing data, which indicates that it is less likely that there is a significant difference between the data and they are all quite similar, as if the standard deviation bars don't overlap much. This suggests the mean of the two data sets are different, and if they are completely different, there is a significant difference. The 2 sets of data that we compared was the participants' results and the static start sprints and flying starts. From this, we found that there was no huge significant difference between the two, as we can see on the screen now. The bar chart shows data in separate columns that is proportional to the values that they represent. where it gives a clear representation, meaning that they are very clear and you are able to see the difference and similarities in the results when looking at this chart. The bar chart that we use gives us a representation of the results we found from the standing vertical jumps of the 15 participants' jumps, where we can clearly see whose were the best jumps and the worst, with the participant 7 being the best and the participant 3 being the worst. A scatter plot displays all data as single points on the graph. It shows the relationship between pairs of quantitative measurements made for the same objective and individual comparing these results. From this you can then identify from the dots whether there is any systematic or causal relationship between the two measurements. With our example, this is not the case, as they are all kind of plotted around the graph, and you wouldn't be able to do a line of best fit. We compared the relationship between height of the participant and their sit and reach scores where there was no relationship. A table is an effective way of presenting data when you wish to show how a single category of information varies when measured at different points. Also, when the dataset contains relatively few numbers of, or if the precise value is crucial to your points. And finally, when you don't wish the presence of one or two very high or low numbers to detect from the message contained in the rest of the dataset, we use a table showing us the participants, their gender, their static sprint score, their standing vertical jump score, and their flying sprint score, with the mean, mode, median, max, and min and range of all of them. A box and whiskers chart does not have any assumptions on the underlying statistical distribution and represents variation in samples of a population. This chart consists of boxes that represents the interquartile range, the mean, and the median of the data that is collected, and the whiskers present the line as the outside of the box, the lines. These whiskers that are in the graph represents the largest and the smallest values in the data that is used for the graph. It can be a case that some data is not used in the graph and individuals' data or outliers are outliers. The space at both ends of the box indicates dispersion in the set of data. The relative location of the median demonstrated within the box indicates skewness. So with our example, here we can see with the blue one, we can indicate that the maximum minimal plot is around 15 millimeters Hg apart, with all of the rest of the data corresponding in that area. With the blue, we can see that the median is in the middle of the box that is the middle and the center of the point of the results found. But with the red box, we can see that the median is closer to the 75th percent in the upper quartile, and the box being smaller than the blue one, so the middle 25th percent to 75th percent, the scores were a lot closer and similar. A histogram is a special form of bar chart where the data represents continuous rather than discrete categories, where it shows the frequency of how often each different values in a set of data occurs. When the data is often grouped to reduce the number of data points and is most commonly used graph to show frequency distribution. The example we used was data from the chess throw, where we categorized it into of scores between 75 from 540 all the way up to 950 in sets of 75, with the highest being 765 to 840 with a score of 6. The normal distribution curve is a bell-shaped frequency distribution curve that is continuously and typically symmetrical, where with this you can find the most out of the data values in this will come from around the mean. The further a data point is in the results from the mean, the less likely for it to occur on the curve. Things like height, blood pressure naturally follow a normal distribution curve. The normal distribution curve typically has a greater range of data within the sets of data, as there is a wider spread through the whole graph. It will normally fall under, with the mean being the center point. You normally find that the rest of the graph will fall under -1 or +1 to the standard deviation, but can be more depending on the results that are used. However, it can occur where the distribution can be negatively skewed and is skewed to the left if the scores recorded are more in the higher side of the scale, with the other scores being a lot lower. When the mean is greater than the median, which will always be greater than the mode, this is positively skewed and skewed to the right. Outliers are bits of data that you record from the testing that are irregular compared to the rest of the data collected, and because of this are usually ignored and not used by the researcher. There are two different ways that this can be done. One being trimming, which is where the researcher takes off the numbers from the data that are anomalies, and then there's also Windsorizing, which is changing the anomaly to the nearest and most acceptable number compared to the rest of the data. Our example here is trimming, where we have had a set of data with three anomalies of 19, 22 and 29, as these numbers are pretty much double or more of all of the rest of the numbers in the results, so we have removed these from our findings. Part 3. Descriptive statistics can be in mean mode or the median. The mean is the measure of central tendency that is calculated by adding up all of the values and dividing the answer by the number of values. This can also be known as the average. Here of our example, we added all of our scores together, where this added up to 518, where we then divided 518 by the number of results we had, which is 14, and which gave us the mean score of 37. The mode is very simple. It is the value that occurs most frequently in a series of numbers from the results that we get. In our example, the mode is 5, as it is a score. It is a score in our results that is scored 4 times, and this being the most frequent number from all of our results. So this therefore is our mode. The median is the middle number of the values given when they have been put in order from the lowest to the highest. If there are 2, you add them up and divide them by 2. So with our example here, we put our numbers in order and found the middle numbers, but with this instinct there were 2, and when this is the case you have to add them up and divide them by 2, like I said. So here we had the two median numbers of 40 and 41, where we added these together and divided them by 2, which gave us the mean answer of 40.5. Dispersion consists of range, standard deviation, and the interquartile range. The range of a list of numbers is just the difference between the largest and the smallest values. So with our example here, we have the largest value of 56 and the lowest being 15. And an easy way of finding the difference between these is to take away the smallest number from the biggest number, which is what we did and gave us the range answer of 41. The interquartile range is a measure of variability based on dividing a dataset into quartiles. Quartiles divide a rank-ordered dataset into 4 equal parts. The values that divide each part are called the first, second, and third quartiles, and they are denoted by Q1, Q2, Q3 respectively. Q1 is the middle value in the first half of the rank-ordered distribution set. Q2 is the median value in the set. Q3 is the middle value in the second half of the rank-ordered dataset. And the interquartile range is equal to Q3 minus Q1, which for us was 27 and 75, so we found the range between this, which is 48, so this was the answer for the interquartile range. Standard deviation is a quantity expressed by how much the members of a group differ from the mean value for the group. It is used to tell how measurements for a group are spread out from the average or expected value. A low standard deviation means that most of the numbers are close to the average, whereas a high standard deviation means that the numbers are more spread out. To calculate the standard deviation, you have to work out the mean, then for each number, subtract the mean and square the results, then work out the mean of those squared differences and take the square root of that, and then you will have your answer. This is what we did with our example, where we finished off by squaring 223.5 and getting the final answer of 14.9.